Lx is a hypothetical population, the number alive at the beginning of age x. Normally in a life table, it's given as 100,000 as the beginning population of a life table, and it's known as the radix. Then we have ndx. This gives the number of people dying at age x in life table population. Then we have nlx, the number of years lived by persons aged x. We have tx, the number of years lived at age x and all other ages. And finally, we have ex, which is the average years remaining at age x. In other words, that's the measure of life expectancy. So we are saying that the life table has a hypothetical population. This is simply the age group, and this is the total population you are given, total population broken down into various age groups. And then you are given number of deaths per population. So in each age group, normally you are given the deaths. And then from these two, you can calculate the age specific death rate. We've already seen how to calculate age specific death rate, having age groups and total population broken down into age groups. Then from there, you can calculate the probability of dying if you know the death rates. And this one is the hypothetical population. Is the population which will help us calculate the life expectancy here. But we are using the current age specific death rates. So this is a real life population. We are taking the measures and applying them to the hypothetical population to help us estimate the expectation of life. So quickly, for the parameters, I said we have x as an age or age group. Then we have npx as our total population. We have d for deaths. We have m as the age specific death rate. We have the q, the probability of dying. We have the lx, which is our hypothetical population, and it starts at 100,000, and it's also known as the radix. Then we have d, the number dying at age x. Now in the life table population, these were the recorded deaths in a real population, but now these are deaths in a life table population. We have L, the number of years lived by persons aged X. We have T, the number of years lived at age X and all other ages. And we have E, the life expectancy. This is how we calculate the parameters of a life table. This is the age specific mortality rate. We simply divide the age group all along from computation. The computation of the parameters of a life table are as follows. We start with the M, which is the age specific death rate. We simply divide the number of deaths in the age group by the population in that age group. And then we have the probability, the proportion alive at the beginning of age X, or the probability of dying. So here's the probability of dying given by that formula. Where A is 0.5, we are assuming that people in an age group die midway. So that's halfway as they are finishing their age group. But for younger ones, so when you have the age group 0 to 1, we don't use 0.5, we normally use 0.85 because mortality is higher in young ones. Even for older ones, the under 5, the children, it's a bit higher. So here we are using the 60.60. The other parameter is the NDX. Calculate NDX by NQX times LX, and then LX plus LN equals LX minus NDX. So as long as you have data, you'll be able to compute these parameters. But we have to take note here, when calculating TX, we use the next age group. So if you are in age group 0 to 1, you'll be using the 1 to 5 age group and so forth. So it's worth, when calculating TX, to begin from the bottom of the table. And then the life expectancy that we are looking for is found by dividing Tx plus n over Lx. That's the end of the computation. But there are some concepts used during the analysis of fertility and mortality. We've been talking about live births and so on and so forth. So a live birth simply means complete expulsion or extraction from its mother of a product of conception, irrespective of the duration of the pregnancy, which after such separation breathes or shows any other evidence of life, such as beating of the heart, pulsation of the umbilical cord, or definite movement of voluntary muscles. Whether or not the umbilical cord has been cut or the placenta is attached. So as long as you have a living person born, irrespective of the duration of the pregnancy, that's a live birth, as long as it has evidence of life. We also have the fetal death or the stillbirth. This is death prior to complete expulsion or extraction from its mother of a product of conception, irrespective of the duration of pregnancy. The death is indicated by the fact that after such separation, the fetus does not breathe or show any other evidence of life, such as beating of the heart, pulsation of the umbilical cord, or definite movement of voluntary muscles. So that's all about mortality, but there is an exercise for you. You should know the importance of having specific indicators or measures of maternal, child, and infant mortality. In other words, why are maternal, child, and infant mortality rates important? Why are they special, unlike other measures? You should also know the reasons why many developing countries are experiencing falling mortality rates, key factors that are contributing to low mortality rates, and finally, know the factors that contribute to high maternal and child mortality in developing countries. We are now going to look at migration measures.